Alright, welcome everyone to our lesson today on irrational numbers. Alright, so the goal for today is to kind of define what an irrational number is, be able to identify them, and be able to estimate them, right? Using the skills we learned in the last lesson on estimating roots. And with all of those skills combined, we can then order those irrational numbers from the smallest to biggest to smallest, all that kind of stuff. Alright, so with that being said, let's actually go over the definition first. So now we have rational numbers, and we have irrational numbers. Right? So those are pretty much the two big groups of numbers we are working with here. So the rational numbers, as we can see, are what we consider as pretty clean. Right? So let's say the square root of 100, right? That gets us 10. The cube root of 8, so what number multiplied by itself 3 times is 8. Right? So that's just 2, because 2 times 2 times 2 is 8. Okay? 0.5. Once again, that's a pretty clean number. Just like a nice small decimal here. 5 to the power of 100. That's a. I'm not even gonna put in the calculator. I don't even think the calculator can calculate this big. Okay, so it's 5 multiplied 100 times. Once again, even though it's a huge number, it's gonna get pretty messy. At the end of the day, there's not really decimals, right? It's just like a nice whole number. And with this right here, with this fraction here, the square root of 9 over 64 is just the square root of 9 over the square root of 64, which is just 3 over 8. Right, so as we can see here, those numbers are like just pretty nice in general. If you're still confused on what I mean by nice, that's okay. Now let's look at the irrational numbers now. The square root of 0.24. So let's put in the calculator. Okay, so from the calculator, we have, oh gosh, what is this? 0.489897, blah, blah, blah. Goes on forever, right? The fourth root of 9, okay, so that's 1.7320, blah, blah, blah. Square root of 2, 1.41421, blah, blah, blah. The square root of 1 over 3, okay, so that will just be 1 over 1.72, blah, blah, blah. All right, so yeah, again, all very disgusting numbers. And of course, this one's not very disgusting. This one's pretty beautiful. Pi, right? 3.1514159, blah, blah. Goes on forever. Okay? So as you can notice here, the biggest difference between the rational and irrational numbers is that the rational numbers just have a nice whole number or a nice clean decimal. And the irrational numbers have decimals that go on forever. Right? Because you can even see here, even the 3 over 8, right? 3 over 8, if we convert that into a decimal, right, we can use a calculator for this. Right, gets us 0.375. So the key difference between rational and irrational numbers is that irrational numbers have an infinite decimal, right? It does not end. Whereas rational numbers have a decimal that just stops at one point, or it repeats in a specific pattern. So now to give a strict definition here, so irrational numbers cannot be written as a fraction, right? So this is the formal definition of it. So irrational numbers cannot be written as a number over a number, aka a fraction. Right? So that's all it is. If we can see right here, the square root of 2, we can't really write that into a fraction, right? It's 1.414 blah blah. We can get close to it, but we can never write a fraction. Take pi here, for example, right? Pi is actually kind of interesting. If we take the fraction of 22 over 7, right? 22 over 7 gets us 3.14285 blah blah blah. Right? It also keeps going. But at the end of the day, this, as big as this decimal is, it can be written as a fraction. Right? So that's what an irrational number is. Even though some have a really disgusting long decimal, at least it ends at one point, or at least it repeats in a predictable manner. So we can take the decimal, or let's take the fraction of 1 over 3. Right? If we do 1 over 3, we know that it's just 0.33333 all the way through, right? So we put a bar over the 3 to say that it's an infinitely repeating 3. Even though it is an infinite repeating 3, we can still write that disgusting decimal as a fraction. Right? So that's what a rational number is. A rational number is any number that can be written as a fraction. An irrational number is something that cannot be written as a fraction. So most likely if you see a long string of decimals, it's probably irrational. Right? And as you can see here, even if we see something like 5 to the power of 100, because it's the whole number, it's fine. Right? Because any whole number, let's just take the square root of 100 here. Right? Square root of 100 is 10. And 10 can be written as just 10 over 1, right? Just 10 divided by 1. So 10 by itself, and any whole number is rational. So with that being said, let's do some examples. So we have a bunch of those numbers. Are the numbers irrational? And if they are, can we try to estimate them? So coming up, 1.21, right? So right off the bat, that one is definitely rational because it's just like a nice small decimal. The decimal does not repeat, does not go on forever. Right? So if we really want to convert it, 1.21 is just 1 and 21 over 100, which is 121 over 100. All right, which means that it is rational. Okay, -3 over 5. Very conveniently, it's already a fraction, which means it is, by definition, rational. Right? Even though there's a negative sign, right? Rational numbers don't really care if it's negative or not. As long as it can be put into a fraction, it is rational. Square root of 14. So right away, we see that chances are it's probably not rational, right? Because when we square root of 14, okay, let's see. So now we have square root of 14. So now we're asking, is there any two numbers that multiply together to get us 14? Right? So if we take, let's say, 3 here. If we multiply 3 together, we get 9. If we multiply 4 together, we get 16. Right? So there isn't a clean whole number we can multiply by itself to get 14. So chances are this right here is irrational. And from our last lesson, we can actually kind of estimate this. Right? We know the square root of 9 is 3, and the square root of 16 is 4. So we know that the square root of 14 is somewhere in between. Right? It's somewhere in between 3 and 4. And because the 14 is closer to 16, we could just say, okay, well, it's probably around 3.8-ish. Or 3.9-ish. Right, if we plug it into a calculator, square root of 14, right, the square root of 14 equals to 3.7416, blah, blah, blah. Okay, so it's going to be a long repeating decimal that does not end. So in other words, we can't really put square root of 14 into a fraction. Okay, next, the cube root of 8 over 27. Okay, so right here, we are saying, is there a number that multiplies 3 times by itself is 8, and multiplies 3 times by itself is 27? Okay, well actually there is. If we do 2 times 2 times 2, we get 8. And if we do 3 times 3 times 3, we get 27. Okay, so the cube root of 8 over 27 would just be 2 over 3. And because 2 over 3 is a fraction, then the cube root of 8 over 27 is also rational. Okay, last one here, -30, cube root of -30. All right, so we know 3 times 3 times 3 is 27. How about 4 times 4 times 4? So that's 64. That's way over. So chances are this thing right here is not rational or irrational. So now if we estimate it, it will be in between the cube root of -64 and the cube root of 27 or -27. So which means that it's somewhere in between -4 and -3. So because it's closer to -27, we can just say it's around like -3.2. Probably 3.1 is closer, actually. It's around -3.1. Let's double check. Okay, right, so the actual answer is -3.107, blah, blah, blah. Okay? Right, so yeah, that's pretty much how we tell rational and irrational. Can it be a fraction? No, then it's irrational. Is it a very messy and disgusting square root looking number? Then if yes, it's probably irrational. Okay, so now with those estimation skills we went over today and our last lesson, let's try to order those numbers from smallest to largest. So right off the bat, we can just punch everything to a calculator and see their exact values. Okay, so the square root of 9, we know is just 3 times 3. So that's just 3. Okay, next we have the fourth root of 27, which is 2.28. Just rounded. Our next one, we honestly don't really need to use a calculator for this because we know it's a negative number, right? A negative number multiplied by itself 3 times is a negative number. So we know no matter what happens, that will be the very last digit. Okay, the cube root of 13, 0.35. And lastly, the square root of 18, right, 4.24. So now all we're doing here is just adjusting them from smallest to largest. Right? Because, right, so on a number line here, let's just say 0 is right here and say 3 is right here. So we know the square root of 9 is at the 3. Cube root of -5, whatever that is, it's going to be negative, so it'll be the smallest number. Root 18 is 4, so it's bigger than the 3. We have the cube root of 13 first, so right there, followed by the fourth root of 27, so right there. Right? And that's pretty much all there is to it. Right? So this is pretty much all the numbers or the radicals and the... Alright, so that's pretty much it. This is us essentially noticing that those are different decimals and us labeling it from the smallest to largest. Okay, so practice time. So we have 5 numbers here. Try to figure out if they are rational or irrational and try to estimate them if they are irrational. Okay, hope you had some time to pause the video and work them out yourself. Let's get to it then. So the square root of 12. Right away, we kind of see that it's not that quite. Because we know 3 squared is 9 and 4 squared is 16. Right, meaning that the square root of 9 is 3, the square root of 16 is 4. So the square root of 12 will be somewhere in between there. Right? Because we know the square root of 12 is between the square root of 9 and 16. It is the in between 3 and 4. This means that the square root of 12 is, let's see, it's actually sort of in the middle-ish. Right? So let's just say 3.5-ish. It's around 3.5. But because it doesn't have a whole number, it's going to be a pretty messy decimal. This is irrational. Irrational. Okay, 4th root of 16. This one looks irrational, but surprisingly is rational, right? If we just do 2 to the power of 4, we notice that that equals to 16, right? So the 4th root of 16 equals to 2, right? Because 2 is just 2, right? There's no ugly decimals behind it. There's no infinite string of decimals that never ends. That is rational. Okay, next, the cube root of 100, negative 100. So right off the bat, we can kind of feel like it could be rational, right? But we realize that if we have negative 10 to the power of 3, we actually get negative 1,000 instead, right? Which is honestly very unfortunate, right? And now let's try something else. So let's take the cube of negative 3. That's negative 27. Okay, we're a little off. The cube of negative 4, that's negative 64. Okay, closer. Negative 5 cube is negative 125. Okay, so right, because it's a negative number, we know that it is bigger than negative 125, and it is smaller than the root negative 64. Right? So it's somewhere in between negative 4 and negative 5. And the negative 100 is closer to 125 than 64, so it will probably be around, say, negative 4.7-ish. And it will be irrational. Oh, got no room here. Alright, this is around negative 4.6416, blah, blah, blah. Okay? Next, we have 1.25. So 1.25, right away, we see that it's a decimal that it just ends right there, which is really nice. Right? So 1.25 is just 1 and 25 over 100, which is 1 and 1 over 4, which is just 5 over 4. Case closed, rational number. Very nice. Okay, so now this one kind of challenges our understanding a bit. Right here, we have 1 and 3 repeating. And now something interesting is that I've been saying this whole time, repeating decimals, not good, or infinite decimals, not good. But because it's an infinitely repeating 3, right? We actually notice that this can be written as just 1 over 3. Right? If we type 1 over 3 into a calculator, we just get an infinite string of 3s. Which means that, surprisingly, even though it's an infinite decimal, it is still rational because you can write it into a fraction. Right? So yeah, that's pretty much it. So rational and irrational, if it can be put into a fraction, it's rational. If not, if you take the root of something, you get a long string of decimals that has no repeat or no ending site, then it's irrational. Right? So that's pretty much it. So keep practicing and stay hydrated.